Hello children. In the previous video, we have seen exponential and logarithmic function, also the graphs of it. And by observing what we have seen is the graphs of exponential and logarithmic functions are nothing but the mirror images. Okay? Then we have seen the properties of logarithmic functions. In this video, we are going to see logarithmic differentiation. Now, if the function is of the form u of x raised to v of x, u of x raised to v of x in the sense your base as well as your exponent are in terms of x. For example, suppose y is equal to x raised to cos x. So my base is also what? X itself, the function of x, and my exponent is also function of x. So in that case, what to do? This method also can be used when you have it as y equal to some a raised to x. Okay, we are going to derive the formula for derivative of a raised to x using this method. But already we have noted what is the derivative of a raised to x. What was the derivative of a raised to x? It is a raised to x into log a. Okay, so whenever you have the questions of the type a raised to x form, you can make use of directly that derivative. Okay, in that case, no need to go follow this all methods. Okay, directly we can make use of that formula. Okay, so we'll see if the problems are some complicated, then what we have to do it. So if the function is of the form u of x raised to v of x, what to do is take log on both the sides. Taking log on both the sides, what will you have? It is log y is equal to log of u of x raised to v of x. Okay? This is the case. Now, can I make use of the property log of a raised to n is n into log of a. So using that property, it is v of x into log of u of x. Okay. After this, what to do is differentiate on both the sides. So it will be d by dx of log y equal to d by dx of the given function on right hand side. Now what is derivative of log y? Yes, it is 1 by y, but since it is with respect to x, it should be multiplied with dy by dx. And on the right hand side, if you see, it is the derivative of which form? Is it the product rule? U of x into v of x. So it will be what? First into derivative of second plus second into derivative of first. Okay? So it is written it here. So derivative of log y, it is 1 by y dy by dx. Then using your product rule, we can have it as first into derivative of log u of x. Log x derivative 1 by x. But it is a composite function. So using the chain rule, it will be 1 by u of x into u dash of x plus second into derivative of first. Hope this is clear. Now multiply your y to the right hand side and you will get the value of dy by dx. Okay, so this will be the answer to find your dy by dx. Is that clear? And at the last, you have to write the value of y. Your y is u of x, v of x. According to your question, you have to write it there. So the procedure, is it clear? Take log on both the sides, use the property, differentiate it, okay? And at the last, substitute the value of y. So, this is the procedure that we have done. In this case, the logarithmic differentiation method is applicable only if the functions f of x and u of x are positive. Okay? That functions, if they are positive, only then we can make use of your logarithmic function. Right? because your logarithmic function's domain is what? It is operated only on what? It is operated only on positive real numbers. Your domain of log is positive real numbers. Logarithmic differentiation is a process by which a complex function can be differentiated by taking logarithm to base e of the function and then differentiating both the sides. Now see, we know that whenever we are taking logarithm to the base e, they are called as your natural logarithms. Okay, usually it is denoted by ln, but in the text it is given just log x. Okay, usually if you write ln, it is nothing but your natural logarithms, or else it is written as log to the base e. But now in the text it is just written log, that means it is treated as natural logarithm itself. Here they are considering only log to the base e. Okay, if it is not specified, it is log to the base e itself, your natural logarithm itself. So we'll be seeing now examples related to this type. See, you have to differentiate x raised to sin x with respect to x. So is it of the form my base is also in terms of x as well as my exponent is also in terms of x. So what to do? Take first whatever the function, take that function as y. So I have y is equal to x raised to sin x. Now what to do? Take log on both the sides. So here log on both the sides, then differentiate it with respect to x. So log y derivative 1 by y dy by dx equal to, make use of your product rule. So it is first into derivative of second plus second into derivative of first. Okay. So you'll be getting it as dy by dx equal to y into bracket sin x by x plus cos x into log x. And the last step is what? Just substitute the value of y. Y was nothing but here x raised to sin x into the given bracket. It is not compulsory that x raised to sin x should be multiplied inside. Okay, you can write it till that, no worries. You'll get the marks. There they have simplified and they have written the answer. Okay, so hope this is clear. Okay, now the next question is very important. Okay, because most of the time that question comes. Now see, find dy by dx if y raised to x plus x raised to y plus x raised to x is equal to a raised to b. This is the question. Okay. Now in the previous we have seen it was only just a monomial. Something, I cannot say it is a polynomial, sorry. It is just what x raised to x, right? That function, it contained only one term. Now here I have 1, 2, 3 functions and all the functions are having what? See here, it is what? X raised to something. Yes, we have like that. So what to do is, we'll be considering each function separately. Okay. So first, we'll be considering your y raised to x as u, your x raised to y as v, and x raised to x as w. Okay. So I have just substituted as your y raised to x as u, x raised to y as v, and x raised to x as w. Directly don't take log on both sides, because that is the mistake I can say 50 to 60% student do. Whenever you see something x raised to something, function of x as well as that base and numerator, what you do is you directly take the log. Okay, I don't have any property for log of m plus n. No property I have. Okay, so don't take log directly, because if that step is wrong, even though in your mind you'll be doing for the rest a rest step. But the first step, since it is wrong, that won't be logically correct. I don't have any property for log of m plus n. We have only for log of m into n. It is log m plus log n. Okay, so don't take log on both sides at this very first stage. If you have plus sign in between that two functions, okay, you have to take separately. So the given function can be written as u plus v plus w is equal to a raised to b. That means if I differentiate it with respect to x, I'll be getting du by dx plus dv by dx plus dw by dx equal to 0. Since your a raised to b is a constant, derivative will be 0. So separately consider your function u, find what is du by dx. Now, your u is y raised to x. Now it is of the function, y is also a function, x is also a function. So what to do? Apply your logarithms on both the sides. So you will get it is log of u is equal to x into log y. What was the next step? Differentiate it on both the sides with respect to x. So you'll be getting it as, it will be what? Log u, derivative of log u. U is function of x and y. So I have to write it as 1 by u into du by dx. Don't forget this, du by dx is equal to, yes, it will be what? X. You have to make use of, see what it was? X into log y. So I have to make use of your product rule. First into derivative of second plus second into derivative of first. So I'll be getting it as x into 1 by y dy by dx plus log y into 1. And I'll be having du by dx as this. Instead of u, substitute the value as y raised to x. Is that clear? Okay. Similarly, the next is your v is equal to x raised to y. So what to do there? Take your log of v is equal to log of x raised to y. That means I can write it as, it will be your log of v is equal to y into log of x. Again the same process, differentiate it on both the sides. Apply the formula for product rule and you will get dv by dx equal to v into the given bracket. And then substitute the value of v. Okay, one more you have u, v, and one more it was, that is w. Okay, so w again the same, apply log on both sides. It will be log w is equal to log of x raised to x. Using the property, it is x into log of x, that is they have written it here. So differentiating both the sides with respect to x, the same steps, make use of u into v form. Again dw by dx you will be getting w into this, that is 1 plus log x. So w was nothing but x raised to x. Is that clear? So we have found du by dx, dv by dx and dw by dx. Now what is the next procedure? Just add all this. Okay, so adding all this, that will be my required answer. So your dy by dx terms, take it together, the rest all terms take it on the other side, and then find what is the value of dy by dx. Hope this is clear. See, if the procedure is clear, then nothing is there in that, because the same procedure we are using. Okay, if you have more than one terms, you have to take separately as u and v and then differentiate and then add it. Okay, is that clear? Now the next type, this is differentiate a raised to x with respect to x. Here we are going to find the derivative of a raised to x. Already we know it is what it is. So what to do here? Apply your log on both sides. So it is what? I'll be having log of y is equal to log of a raised to x. Making use of property, it will be log of m raised to n is n into log m. So I'll be having it as log y is equal to x log a. So differentiating both the sides with respect to x, will be having derivative of log y is 1 by y dy by dx into log a is constant. So derivative of x will be what? It is 1. Okay. So just only will be getting it as log a. Now multiply that y towards there. So I'll be getting it as what? I'll be getting dy by dx equal to y into log a. Is it clear? So directly we can say what? Derivative of a raised to x is what? A raised to x log a. This is already we have seen. Okay. Alternatively, that what they have done is they have written d by dx of a raised to x as e raised to, see it is e raised to log of a raised to x. These two are inverse. Log and exponential are inverse. So this and this will get cancelled. Okay. So here we can write it as what? D by dx of e raised to x into log of a raised to x. A raised to x, they have written up this form. So derivative of d by dx of e raised to x log a, that is nothing but e raised to x log a, and again composite function. So find the derivative of that and you will get the answer. Okay. But this will be the easiest method that we have done, taking log on both the sides. Is that clear? The next type, if you have differentiate square root of, it may not be square root, it may be nth root, it may be fourth root, fifth root, sixth root, whatever it is. See what is here. If I am writing here, if it is nth root of x, how we write? Is it x raised to 1 by n? Okay, that should be kept in the mind. So when, even though the question it is your nth root of something is written in your square root or nth root, no problem, it is very easy. So what to do here? Just I can write this as, I can write it as y it is equal to the whole function bracket raised to 1 by 2. Okay. Then what to do? Take your log on both the sides. So taking log on both the sides, you'll be having what? I'll be getting log y is equal to log of this bracket raised to 1 by 2. So it is log of m raised to n. So it is what? N into log of m. That is what they have written it here. Log y will be 1 by 2. It will be what? Log of this one, this function. Okay. But log of m by n is what? Log of m by n is nothing but your log of m minus log of n. And log of m into n is what? Log of m plus log of n. So everything they have done in one step, and you will get it as log of x minus 3 plus log of x square plus 4 by using the property. Log m into n is log m plus log n. Then log m by n is log m minus log n. So minus, okay, log of 3x square plus 4x plus 5. Then differentiating with respect to x, we get 1 by 2. It will be right hand side. Log x derivative is 1 by x. So here it is 1 by x minus 3 into derivative of x minus 3. Into derivative of x minus 3 is what? 1 itself. So nothing to write. Again, log of x square plus 4, it is 1 by x square plus 4 into derivative of x square plus 4, that is 2x. Similarly, for log of 3x square plus 4x plus 5, you will get it as 6x plus 4 by 3x square plus 4x plus 5. Okay? And hence, this will be the answer. Just substitute the value of y and you will get the answer. Okay? Hope this is clear. Okay? Thank you.